RC series circuit using Laplace transform. Now in this video, I'm going to solve the RC series circuit using the Laplace transform. If we apply the Kirchhoff's voltage law in this loop, we will have V is equal to R times I of t plus, now the current and the voltage relation for the capacitor is 1 by c integral of I of t dt. And here if we apply the Laplace transform, okay, applying the transform, we will have, okay, Laplace of v is equal to Laplace of Ri of t plus c integral I of t dt. Okay, we're going to apply Laplace in both the side. And now the Laplace of this one, okay, Laplace of this one is like the Laplace of constant c is equal to c by s. And we also have Laplace of I of t. Okay, this function will be equal to I of s in the frequency domain. And then we have Laplace of integral I of t dt is equal to I of s divided by s. So these are the standard formula that we have. So if you check the Laplace transform table, so these things will be available. Now let's directly substitute here. So Laplace of v, so c is constant here. Now looking at this graph, our v is also constant. This is the DC source, so we will have v by s is equal to, now r in our case is constant, so we, this constant, I mean this is the multiplication factor, it's kind of multiplication factor. This is multiplying with the current I here, so it will be I of s plus, then we have a constant 1 by c, and we have I of t, which, like when you take the Laplace transform for this one, is giving like this. And now we have to arrange. Now let's arrange our let's take the like terms, r plus 1 by c s. Okay, now let's make this okay, r as subject, no, that is as subject, then it will be equal to v by s times 1 by r plus 1 by c s. And then let's do some simplification. Let's take the common in the denominator. Let's try to take the r as a common term for both the sides, for this one and this one. So it will be v by r times 1 by s plus 1 by r c. Now with this we have come into the standard formula. Now when you apply the, okay, when we apply the inverse Laplace transform, so we will be able to take this one. We have made this one into the standard formula. So Laplace inverse of I of s is given by this, and then Laplace inverse of 1 by s minus a is equal to e of at. Now in our case it is like Laplace of 1 by s plus a, so here we can write it as minus a of t. So which means, let's apply the Laplace inverse of I of s. Okay, then v by r of, okay, Laplace inverse of 1 by s plus 1 by rc. This rc is constant. Okay, so for this one you'll have I of t is equal to v by r, and then Laplace of this one is e raised to minus 1 by RC of t. So this is the solution for the RC series circuit. Okay, in the like from here we can calculate the current. So that's it.